Okay, here we go. For day 17, we are starting off by solving some multi-step equations. So some of them have one step, some have two, some have three or more. Let's look at number 1 first. I have 5 plus n divided by 2 minus 7 equals 4. What's our first step? We've got 2 options here. Yeah, we could do minus 5 to get rid of this plus 5, or we could do plus 7 to get rid of this minus 7. It doesn't matter which one you do first. Let's start with this minus 5 because that's what we said first. So we'll do minus 5. And where else do I need to subtract 5 from? Under the 4, right here. So remember, whatever I do to one side of my equation, I can think of there being an imaginary line where my equal sign is. This is one side, this is the other side. I've got to do the same thing on both sides. So I have subtracted 5 from both sides. My 5s are going to cancel, and I'm going to bring everything that's remaining down. So I have n divided by 2. I have minus 7. I've got equals. And then what is 4 minus 5? 1. Is it negative 1 or positive 1? Negative 1. If I've got 4 and I take away 5, that's more than I had before. I'm going to have negative 1. I took away more than I had. All right. Any questions up to this point?
How come he didn't put, why did we put the 5 versus the 4 instead of 7?
Great question. So whenever we have an equation like this, let me show you on a sticky note so it's different. I'm going to just rewrite this equation. Okay. So with any equation, let's, for example, do n divided by 2 minus 7 equals 4. This is not the whole equation. This is just part of it. What I want to show you here is that when I say we need to do the same thing on both sides of the equation, what tells me that I have crossed to the other side is the equal sign. So here's my line. The equal sign separates this side of the equation from this side of the equation. So I already took away 5 on this side. So to keep that equal sign true, I've got to do the same thing on the other side of the equation. So let me, I don't know why I wrote that. That wasn't even the thing I was trying to show you. 5 plus n divided by 2 minus 7 equals 4. So an equation like this, because it's longer, it just looks different. It's the same thing. We know that this equal sign separates our equation into 2 sides. What this means is that this whole problem is the same thing as 4. This whole thing is the same thing as 4. 5 plus a number divided by 2 minus 7. When we do this whole equation right here, this whole expression now, because I got rid of the equal sign, that is going to be equal to the number 4. So if I take away 5 from this side of the equation, I've already taken away 5 over here. If I take it away again under the 7, that means I've actually taken away 10 on this side. I only want to do it once on this side, then I do it on the other side because there's an equal sign.
So the equal is basically divided into 2.
Yeah, the equal sign divides the 2 halves of the equation. So what I've seen a lot of people do, and I would suggest it seriously, if it helps, before you even start, draw a line through your equal sign. Make it your separator between the two sides of your equation. You could do that at every step. Now I have n divided by 2 minus 7 equal. That means this is my two sides. Whatever I do over here, I do over here as well. Does that make sense?
Yeah.
Okay, good. Good. Yeah, no problem. Okay, so now we have a whole new equation. We have n divided by 2 minus 7 equals negative 1. What do I need to do to get one step closer to my answer?
Would you divide?
So we have division here, and we have subtraction here. Yes, because we're using the inverse order of operations. When we solve an equation, we working backwards. So if I want to get rid of this minus 7, what do I need to do? I need to add it. I need to do the opposite. Anytime we're solving equations, we're always doing the opposite. So I added 7 here. Where else do I need to add 7? Underneath the negative 1 on the other side of the equal sign. All right. So my 7's cancel out, and I'm left with n divided by 2 on this side of the equal sign. Then I've got my equals. Then I have negative 1 plus 7. That's the same thing as 7 minus 1. Is anybody uncomfortable with that?
You said it's the same as negative, 7 minus negative 1?
So negative 1 plus 7, what I said is it's the same thing as 7 take away 1. When you add a negative number, you're really just subtracting. Do you guys remember that? Okay, so if I do negative 1 plus 7, I'll do it on my calculator too to show you that it is the same. I'll do negative 1 plus 7, and I'm going to get positive 6. Just like if I did 7 minus 1, I'll get positive 6. Okay, so now we have a whole new equation again. Here was step 1. Step 1, we took away 5. Step 2, we added 7. Step 3, what's the last thing we're going to do here? We have n divided by 2. Yeah, we need to do inverse operations. We have divided by 2, so to reverse it, we're going to do times 2 on both sides. All right, my 2's are going to cancel. I can bring down my n equals, and then what is 6 times 2? 12. All right. If you did not get n equals 12 as your answer, do you understand now why it is n equals 12? Does it make sense, or do we have any confusion?
No, it makes sense.
Okay, good. Any questions before we try number 2? All right, let's look at number 2. Number 2, we have n divided by 5 plus 2 equals 12. If it helps you to keep things separate, go ahead and write a line through your equal sign so you know here's one side of my equation and here's my other side. Whatever I do over here, I must do over here as well. What should I do first? Yeah, let's get rid of that 2. Minus 2, both sides. All right, what happens next? Yeah, you're right. These 2 cancel out, and then what you said before, everything comes down. N divided by 5, nothing else. So I've got equals 12 minus 2, 10. Perfect. All right, what should I do next? Yeah, we've got n divided by 5. If we're trying to get rid of division, we do the opposite, which is multiplication. So we want to multiply by 5 on both sides. All right, what happens now? Yeah, our 5's cancel, so we can bring it down to n equals, and then what did you say? 10 times 5, what's that?
Oh, shoot.
50. That's okay. That's okay. You had the right idea. N equals 50. If you did not get n equals 50, do you recognize what needed to happen differently? Does everybody feel okay about number 2? If you don't, you can say so. I'm here to help.
So the first step is always, well, not always, because it's an addition.
Uh-huh.
So because it's an addition, we do the opposite, which is subtract.
Yeah, so let's go ahead and just review the rules for when we're following equations with more than one step. So I'm going to write here, solving equations. Your first step, remember we go in backwards order of the PEMDAS. So step 1 is to get rid of addition and subtraction. And then step 2 is once all addition and subtraction is gone and taken care of, we take care of multiplication and division. And in order to get rid of these items, we use inverse operations. And those inverses, if we remember, if we have addition or a positive number, the opposite of that, or the inverse, would be subtraction or a negative number. And then if we have multiplication, the opposite of that is division. So this is just a little reminder of what we've been working on. And we can kind of follow this guide for these types of problems. Do we feel like we can move on to number 3? Okay, let's look at number 3. And we'll keep this beside us so we can keep track of what we're doing. Number 3 says negative 3 plus 2 times n minus 2 equals 15. What do we need to do first?
Would we add 3?
Yeah, we could add 3 first. Let's do that. Plus 3. And where else do we need to add 3? Under the 15. Because that's on the other side of our equation. We already did it over here. So we got to do it over here now.
The lines help a lot.
I think so too. I should be doing that from the get-go. I'm going to start doing that. Because I think there's just too much going on in one straight line. This is, I agree, it's helpful. Okay, our 3's cancel. Now, let's rewrite what we have left. We still have 2 times n minus 2 equals 15 plus 3. What's that? 18. Good. Okay, now let's check our next step. We have 2 times n minus 2. Have we gotten rid of all of our addition and subtraction yet? No, we haven't. What do we need to do then?
We add 2.
We need to add 2. Perfect. We want to get rid of this minus 2, so we're going to do plus 2. And remember, here's our line. Where else do we add 2? Under the 18. Perfect. So my 2's are going to cancel, and that leaves me with 2 times n on this side of the equation. And I've got my equal sign, and what is 18 plus 2? 20. All right. Am I done? No. I still have more to do, guys. I've got 2 times a number. I'm going to divide. Very good. We're going to use those inverse operations. Divided by 2. And there's only one thing left to divide by 2 as well. It's that 20? So my 2's will cancel, and I'm left with n equals, what's 20 divided by 2? 10. That's it, guys. You did it. It looks scary, and it's a lot of steps, but if we slow it down and do it bit by bit, it's not that bad. We're just adding and subtracting and multiplying and dividing. Any questions about number 3? Any questions at all? If not, we're going to try number 4. All right, let's move on. I gave you a simple one here at the end. This is just a one-step equation. I've got 5 times n equals negative 25. What do I need to do here? Divide. 5 times n, we're going to divide by 5. Use that inverse operation to get rid of it. And there's our 2 sides of the equation. So we also got to do it to negative 25. Now the only thing I'll warn you on here is pay attention. This is a negative 25. So my 5's cancel. I'm left with n equals, and then what is negative 25 divided by 5? Negative 5. Good job. All right, that's all there is to it, guys. Any questions about that process? Okay. Are we feeling confused about anything at all? Is anybody like freaking out?
I just trying to figure out, because I think it's the negative 25.
Yeah. Are you confused about how we got n equals negative 5?
I mean, I know the math part, I mean, I get it, but it's
Mhm.
just that negative. I don't know why I think it should be positive.
So if I have, let's think of it this way. I have a debt right here. I've got negative $25. Okay, I have a debt. That's how much I owe, is $25. And then what I'm going to do here is the same thing we did in this problem. I'm dividing it into 5 sections. So let's say I have 5 friends that are going to help me pay off my debt. So here's friend number 1, number 2, number 3, number 4, number 5. Okay, each friend is going to split this evenly. So if I were to count it out, first of all, every time that I share a piece with each friend of my debt, they're each going to be getting debt as well. So if friend number 1 is paying off $1, for example, that means he's going to have negative $1 because he's going to be paying that. I'm not giving him $1. He's paying it. So if I were to split my $25 debt between my 5 friends, each friend is going to owe $5 each, because 25 or negative 25 divided into 5 portions is going to give us a total of negative 5 in each spot. So I've got negative 5 for this person, negative 5 for this person, negative 5 for this, negative 5 for this, and negative 5 for him. So let's talk about what division really is. All we're doing when we are dividing is we are splitting this number up into equal sections. So let me show you in a different way. So this is just a little multiplication review and division review for everybody. If I have negative 25 and I want to split it into, here's 1 group, 2, 3, 4, 5. Okay. So what I'm going to do is I'm going to start by putting taking away -1 each time and equally putting it into each spot. So I'm going to start with -25. I'm going to put one of those here, and now I've got -24, -23, -22, -21, -20. Okay, so what I did is I put -1 in each box, and now I've got -20 left. So let's go again. I'm going to put -1 in each box all over again. Let's do -1, now I'm at 19. -1, now I'm at -18. -1, now I'm at -17. -1, now I'm at -16. -1, now I'm at -15. Okay? So now here's my total. Everybody's got -1, -1, they've got a total of -2 in each spot. If we kept going on and on until we get down to 0 left, we split all the negatives up, we'll get a total of every person having -5 in each spot. So whenever you are splitting up a negative number, you're coming up with what you need in each group to create the original number of -25. So really, if I added all these together, -5 plus -5 plus, let's do another one, -5 plus -5 plus -5. Okay, this looks confusing, but 5, 10, 15, 20, 25. When I add all that together, I get -25. If I was working with +25, then every time I put a piece into each box, I'd be putting +1, +1, +1, +1. But just because it's a negative, you are going to get a negative answer when you are dividing into sections like this. The only thing that would change this to positive is if we used another negative, because 2 negatives cancel each other out. Okay, so if you start with a negative, like here, we have -25, and we divide it by a positive, that answer is going to stay negative always, unless this was negative over here. Because then if I took -25 divided by -5, these two minuses would come together and turn into a plus. So different signs give you a negative answer, same signs give you a positive answer. Okay, I hope I didn't make it more confusing.
No.
I feel like I might have. I feel like as I was explaining that, I was like, you know, this isn't helping.
No, it was good.
Okay. Well, hopefully it makes a little sense. Any other questions? All right, let's move on. Okie dokie, we did our do now. How do we feel in general about solving equations that have more than 2 steps? Like if I had one like number 1 here, how comfortable do you guys feel about getting rid of the addition and subtraction and then the multiplication and division? Do you feel somewhat confident about that? Feeling okay? All right, let's do 1 or 2 of those together. Just make sure we feel really certain about it. Then I want you to do another one on your own. And then we're going to learn something new today after that. I want you guys to feel very good about it before we move on to the next thing. Okay. So let's run through another one together. I have -3 plus 2 times n minus 2 equals 15. All right. So remember these steps we talked about. First, we get rid of the addition and the subtraction. Then we do our multiplication and division, and we use inverse operations to get rid of each item. So we have two different choices for where we could start. Where do you guys want to start?
Add 3.
That's what I did.
Yeah, let's add 3. You did that too, Rhonda?
Yeah.
Awesome. Add 3. And I should have asked you guys, but where else are we adding 3? Underneath the 15. Good. Okay. My 3's do what? Cancel. What do I do now? Bring it down. I still have this left. Oh, did we really? I just came up with this on the top of my head. I swear.
Yeah.
I thought I was so creative. I was like, man, this is going to come out to a good answer, too. Okay, well, darn it, guys. How about this? Let's do negative 3 plus 4n minus 5 equals, let me think about something that's going to work. 5, 6, 8, 6. This might work. I don't know. We'll try that. Okay, what should we do?
Add 3.
Add 3. Where else am I adding 3?
24.
To the 24, because it's on the other side of my equation, other side of the equal sign. 3's cancel. Okay. I want to make sure everybody's caught up with me. I don't want to move on until you've got it written down. Everybody ready for the next part? Okay. What do I need to do now? My 3's canceled.
Bring everything down.
I got to bring everything down. So on my left side of the equation, I still have 4n. So let's write that. 4n. I still have minus 5. So I'm going to write that as well. Then I have my equal sign. And I need to figure out what 24 plus 3 is. What's that? 27. Good. So I'm going to write my answer right below it. Okay. Now I have a whole new equation. I have 4 times n minus 5 equals 27. What should we do?
Add 5.
Yeah, let's add 5. Rhonda, I see your face. Tell me why you're making that face. What are you thinking? Are you confused?
Okay, because it's times 5, that's why we're, okay. I think it's because I'm looking up top and we've already done the addition part, so I'm trying to figure out.
Okay. So what we're doing here, where it says number 1, addition and subtraction, that doesn't mean, okay, we did addition, now we got to do multiplication. What it means is we're going to keep looking for addition and subtraction at every step until there's none left. We want to get rid of all of it. So in the first step, we found something that we needed to add. Now in the second step, before we go on to number 2, multiplication and division, we want to check, is there any more addition and subtraction so that I know I'm ready to move on.
Okay.
So now that we know that, I'm going to have you answer this, Rhonda. We've got 4 times n minus 5 equals 27. What do you think our next step should be?
To add 5.
Yes, we're going to add 5. And where else should I add 5? Underneath the 27. Again, if it helps you to draw the line in between the equal sign, do it. Okay. What's going to happen with my 5s? They cancel. Then what?
Bring down the 4.
We're going to bring down our 4 times n. Then we'll bring down our equal sign. And now we just need to find out what is 27 plus 5. 32. All right. Now we have a whole new equation again. We have 4 times n equals 32. So let's look at our steps. Do we have any more addition and subtraction?
No.
We do not. So that means now we can look for multiplication and division. So, do we have multiplication or division? We sure do. We have 4 times n. What do I need to do here? Divide. We want to use our inverse operations. If I see a multiplication problem, to get rid of it, I divide. Oops, I don't know why I wrote 2. 4. Dividing by 4 on both sides. Because I'm trying to get n by itself. So my 4's cancel, and then I'm going to get n equals, what is 32 divided by 4? 8. Very good. All right. How do we feel? Feel okay? Do we feel okay enough to introduce something new? Okay, before we do, I want you to prove it to me. I'm going to give you a problem to do by yourself. I'll give you 5 minutes to do it. And then I'm going to double check that y'all all got it. Then we're going to learn something new. So, here is a problem. Let me find one that's not the do now. How about... I want you to do 10 plus... Okay, 10 plus 2 times n minus 10 equals 40. I'm going to pause this video. All right, so I've got 10 plus 2 times n minus 10 equals 40. What should I do? Subtract 10. Sure, let's get rid of that. And then where else am I subtracting 10? On the other side of my equal sign, under the 40. Perfect.
So do we have to subtract it?
Huh? Say that again?
I added 10.
So, did you do this one first?
I think so, yeah.
I bet you did. Because we're going to be subtracting 10 to get rid of this one, but we're also going to be adding 10 to get rid of this one. It doesn't matter what order we do it in, as long as we do them both.
Okay.
All right, so we'll go from here. I've got this left on this side of my equal sign, so I'm going to bring it down. And I've got 2 times n minus 10 equals 40 minus 10 is 30. Now I have a whole new equation. I have 2n minus 10 equals 30. What do I need to do here? Add 10. I want to get rid of this minus 10 before I can mess with any division or multiplication. Where else do I add 10? Under the 30. Good. So my 10s will cancel. There's that line again. I'm going to get only 2n is left over here, so I'll bring that down. So I have 2 times n equals 30 plus 10 is 40. Now I have 2 times n equals 40. What is left to do? Divide. To get rid of multiplication, we divide. So I'm going to divide that by 2. And what I do to one side, I've got to do to the other. I'm going to divide 40 by 2. And that's going to leave me with n equals 40 divided by 2 is 20. Did we all get that?
Yeah.
What'd you get,
I
Darika?
got 30, and I think because I added it to my whole thing off.
Did you add twice, maybe?
I did 10, added 10 under the 10 and the 40, and then I did 2n minus 10 equals 50, plus 10, and then...
Oh, so you kept this, and
Yeah.
you did start with this one first, but you accidentally added instead of subtracting. So you just forgot the inverse operation.
Yeah.
Okay. But as long as you understand what you did wrong and it won't happen again, then we'll move on. You feel okay about it?
Yeah.
Okay.
So since the subtraction is behind the 10, that's why we subtracted 10?
Right here
Yeah. Or is it?
or right here? So we're subtracting 10 because what we have here, I'm going to just rewrite it. It's 10 plus 2 times n minus 10 equals 40. The reason that we are subtracting 10 to get rid of this is because it's a positive 10. We have a positive 10 and we can see here that we're doing plus 10.
And see, that's what I changed my negative into a positive and then I added 10. So I
Gotcha. Yeah, so what we're always trying to do is we're trying to get rid of each one of these terms. And if I've got a positive number, I subtract.
Okay.
Yeah, okay. Are we ready to learn something new? Are we? Are we ready?
Yeah.
I hope so. We're going to do it. All right, guys. I want to teach you about an exception to the rules. So, normally when we are solving equations, we start, and I'm going to just write these steps out again. Step 1, we look for addition and subtraction. Step 2, we look for multiplication and division. And remember, within each step, you may be repeating it over and over and over. So, like in our do now, we first subtracted 5 and then we double checked to see, do I have any more addition and subtraction? And I did, so we added 7. So we did that first step twice. If there was another one that we had to add or subtract, we'd do it 3 times. We're going to do each step until there's nothing more within those categories, okay? So when we solve an equation, this is the order that we do it in, unless we have something like this. What if I had a problem that said 2 parentheses 3n plus 4 equals 20. What if I had something like this? Let me write a little title first. Okay. So, if I had a problem like this, Holly, you said you think we would do the addition first?
Yeah.
Okay, so like the plus 4, you mean?
Yes.
And do minus 4?
Mm-hmm.
Okay, so let's try that. Minus 4. Where else would I do minus 4? Under the 20. Okay, minus 4. So, where would we go from here?
Bring it down.
Like these cancel and then bring everything down? Okay. Let's just, we're trying, we're experimenting here, guys. So we'll bring down 2, 3n equals, that'd be 16. Okay. Let's try that. What do you think we would maybe do next?
What we do 2.
The 2?
What we do is the parentheses first.
I don't know. What do you think? Let's just play with it first. Let's just try some things, and then we'll check our answer and plug it back in.
Should we distribute it?
Oh, Rhonda said, should we distribute it? What do you think? Should we?
Like the 2 times 3,
We could. You want to try that?
2 times 3 n, and then the 2 plus the, 2 times the 4.
Okay, so that's a different way of doing it. Let's try this. Let's write this out to the side over here. 2 times 3n plus 4. So Rhonda, you're saying maybe we should distribute first? Let's try that. Okay, so I'm doing 2 times 3n, and that would give me what?
6.
Yes, 6. We're multiplying. 6n plus, what's 2 times 4? 8. And then equals 20. Okay. That's a way we could try. Let's keep going with each of these, okay? So let's go back to our purple. If we got to this, what would we do here now? What do we think? Give me some ideas. We're just trying stuff. Sure, let's divide the 2. All right, get rid of the 2's. We're just trying things, guys. Okay, so that leaves me with 3n equals 8. All right, and then what? Divide by 3? Okay, let's try that. Divide by 3, divide by 3. And we'd get n equals 8 divided by 3. That's about 2.66666 forever, so we'll round that 2.7. Okay, so we got n is 2.7 for this way. Let's finish the other way we were trying. We tried distributing first. Okay, now we have 6 times n plus 8 equals 20. What should we do next here? Yeah, we have a plus 8 here. We want to get rid of it. So what do our inverse operations tell us to do? Yes, we have a plus 8, so we want to actually do minus 8 to cancel it out. The goal is to do the opposite so that we can get rid of it. So where else do we need to subtract 8? Under the 20. Good. My 8's are going to cancel, so I'm left with 6 times n equals 20 minus 8. I believe that's 12. Okay. And what next?
So when we divide?
Yeah, we have 6 times n. To get rid of times or multiplication, we divide by 6 on both sides. My 6's cancel, and I'm left with n equals, what's 12 divided by 6? 2. Okay, guys, so let's talk about this. We got 2 different answers. We got n equals 2 when we distributed first. We got n equals 2.7 whenever we did our addition and subtraction first. How do we know which one's right? I don't know, girl. Well, let's find out. Let's find out. All right. So what we're going to do is take that original equation. Let me write it out again down here. The original equation was 2 times 3n plus 4 equals 20. So to figure out which one is right, we're going to take both of these values and plug it in to n in our original equation and see which one is correct. So which one should we try first? 2. Yeah, let's try 2. That's a nice even number. Okay, so all I'm going to do here is do 2 times 3 times n. We said n is going to be 2, so I'm really just doing 3 times 2. I'll do that in red so you can see what we put in. Plus 4 equals 20. Okay. Now, we're not solving for a variable anymore. We know that n is 2, or at least we think it is. What we need to figure out is this answer actually equal to 20? If it is, then we're right. So let's use our order of operations, not inverse. This time we're using the regular thing. And let's figure this out. So first, do we have any parentheses? Yes, we do. We have 3 times 2 plus 4 in parentheses. So inside of my parentheses, do we have exponents? No. Do we have multiplication or division? We do. Okay, we've got 3 times 2, which is what? 6. And we're going to add 4 as well. Bring it all down. All right. What's 6 plus 4? 10. All right, now we're left with 2 times 10. What's that? 20. Is that equal to 20? It is. So guys, Rhonda was right. If we have, very good, very good. If we have an equation with parentheses in it, where we have a multiplication problem, anytime that we have numbers in parentheses, just like whenever we were combining like terms and doing all the polynomials and stuff, we don't know what n is yet. So I can't get rid of 4 until I do what is happening in this whole side. I'm doing 2 times this entire quantity. So I have 2 options here. Let me show you the 2 options. 2, 3n plus 4 equals 20. So whenever I'm solving an equation and I see this type of thing going on, I see where I need to distribute 2 into 3n and to 4, I've got 2 options. I could do what we just did, where we just did the distribution. We did 2 times 3n and 2 times 4 and then solved normally. Or I could say I have 2 times whatever this is. We don't know what this is yet. What if we just divided by 2? And got rid of it. We could do that, guys. We could totally do that. This, remember, distribution it's just a multiplication problem. It just looks a little scarier, looks a little different. We're really just doing 2 times whatever this number is. So divide by 2 to get rid of it. We do the same thing on the other side. And then we'll bring down what's left. We still have 3n plus 4 equals whatever 20 divided by 2 is. What is that? 10. Then we just solve like normally. So I've got multiplication and addition. Which one do I do first? The addition. We want to get rid of it by subtracting 4. I'm going to do that on both sides. My 4's are going to cancel out. So then I'm left with 3 times n equals 10 minus 4 is 6. All right, I'm going to wait a minute, let everybody get caught up to there. And guys, what are we going to do to get n by itself finally? Divide by 3. Good. So we're going to divide both sides by 3. My 3's cancel, and I get n equals what? 2. So guys, I got that correct answer both ways. If you see a problem where there is distribution, you either need to distribute first, or you need to get rid of the multiplication by dividing.
So we can do either way though, right?
Either way. Yes, either way. So now that we've introduced that, let's do a couple of examples. let's make sure that we can get some practice. I think sometimes the first time you see something, it feels very uncomfortable, but the more we do it, the easier it feels. Okay, so let's try 5 times the quantity 2n minus 3 equals 25. So we have two options here. We could either distribute the 5 or we could divide the 5. I'm going to write it out twice so we can just do both ways besides each other. I'm fine if you never do one of the ways. If you decide you want to distribute every time, do it. If you decide you want to divide every time, do it. I'm not going to be upset if you like one better.
So we automatically, if we're going to do the division,
Mm-hmm.
we automatically just divide the 5 because it's outside the parentheses.
Yes, yes. So we've been talking about how we have reversed the order of operations for solving equations. However, I didn't get as deep into the explanation because we hadn't introduced this type of equation yet. The only thing that's really reversed is the addition, subtraction, multiplication, and division. If you see parentheses, we are still going to do that first. Yes. So let's do the distribution method first. We can't mess with things in parentheses, so we want to get rid of them. We'll do 5 times 2n minus 5 times 3. So what is 5 times 2n? 10n minus, oh, I didn't write my n. Okay, there we go. 10n minus, what's 5 times 3? 15. Good, very good. So we've got 10n minus 15 equals 25. Now we just solve like normal. I'm going to trace over this because I feel like I made it really difficult to read. Yes, we are. We're adding 15 here. So plus 15 to both sides. My 15s are going to cancel, which leaves me with 10 times n equals what? 40. Now what's our final step? Divide by 10 to get rid of it. Good. And our 10s cancel. We get n is equal to 40 divided by 10 is 4. Amazing.
Yay!
Yay! Good. Awesome. Okay, now just for fun, let's do it the other way. Let's say we don't want to distribute, and we just know that this means 5 times this. We could just divide by 5 on both sides. Get rid of it. And now we have 2n minus 3 left on one side equals, what is 25 divided by 5? 5. All right. What are we doing next?
Divided by 3.
Dividing by 3?
I mean, adding.
Yes, we're adding. Very good. Okay, so plus 3, where else am I adding 3? Under the 5. Good. All right, my 3's are going to cancel. Then I'm left with 2 times n on this side. And on my other side, 5 plus 3 is 8. And what's my last step? Now we're going to divide. Good. We're going to divide both sides by 2. That cancels, and I'm left with n equals 8 divided by 2 is 4. We got the same answer, guys. Both ways work. So if you forget one way, do the other. You've got kind of a net to catch you here. If you remember to distribute, great. If you remember to divide, also great. Okay, let's do one more together. And then we are so out of time, guys. I'm going to have to just give you your exit ticket. I want to keep going today, but we got to move on. Okay, let's do, and I'm going to tell you right now, this equation that I'm giving you at this very moment, whether you're here in class or you're watching on YouTube, this equation is one that you should probably make very colorful in your notes or do something to remind you where it is, because it's going to look familiar later whenever we take a quiz one day. So just a little heads up, you're going to see this exact problem again one day. So make something to tell you that it's here. All right. You guys trying it on your own? Or do we want to do it together?
Oh, we can do it together.
I don't care. What do you guys want to do?
Oh, shoot. I just started and I ain't even got the whole. Oh, goodness. Let me start.
That's all right. So how about this? I'm going to have you guys, kind of similar to what we've been doing, I want you to kind of speak your steps to me. And I'm just going to write down what you tell me. I'm not going to tell you if it's right or wrong. Okay? I'm going to kind of work it out with you. What do we want to do first? I don't care who tells me.
I'm distributing.
Okay, distribute. Did you do that too?
Yeah.
Okay, everybody distributed. So we did this. And what did we do next?
Multiply.
Okay, so what numbers did you multiply?
6 times 7,
What'd you get?
42.
Okay, so I'm gonna write 42.
42 in.
Yeah.
Minus 6 times 7,
Mm-hmm.
42
Yeah, minus 42.
equals 210.
Okay, equals 210. Did you all get this so far? Are we at the same point? Right. Now what?
We're gonna add 42.
Yeah, we're gonna add 42. Where else am I adding 42? Under 210. Good. And now what?
Cancel out.
Yeah, let's cancel our 42s. Mm-hmm. We're gonna bring down 42 in equals 252. Now what? Mm-hmm. Divide 42.
Okay, wait a minute.
All right, stop me. What's going on?
I think I wrote it wrong, so it threw me off. I got n minus 42. And it should be 42n.
Ooh, yeah, so did you accidentally write plus 42 or minus 42 under the one with the n on it? Or did you just bring down the wrong thing on accident?
I think I just brought down the wrong thing on accident.
Okay, because I do see right here there is a n minus 42, but these are,
I canceled out the 42,
That's
so
all
I
right.
should've brought down the 9 only.
yeah,
I mean,
so
n.
these are two separate items here. Then we canceled that, so what you were bringing down was this 42 times n,
Okay, yeah.
right?
Yeah.
Okay, good. All right, so now we're at the part where we are dividing by 42 to cancel them and get n by itself. What else do I need to do here? Yes, I did it on one side of my equation. I have to do it on the other side. And then what is 252 divided by 42? What'd you say? 63? Did we all get 63? I'll check.
Oh, I see what I did.
Let's see. I got 252 divided by 42. 6. Oh. Uh-oh, what'd you do?
4.
Ah! Yeah, dividing by 4 might give you a slightly different answer. That's all right. That's all right. So that was just a calculator error. That's why we just be super, super careful. So you should have gotten n equals 6. Great job, guys. Y'all are doing really well, okay? I'm proud of you guys. Let me get your exit ticket, because as much as I would love to do more practice with you today, that is all we have time for. Here is your exit ticket. Just 2 problems. And if you have somewhere to be, I do want to give you a time warning. We've gone over by 2 minutes. It is 3:27. So if you need to turn this in tomorrow or the next day, that's okay. If you want to stay, that's also okay. All right, I'm going to end this video and put it on YouTube.